All right, so what we're going to look at now, and since there's so many similarities between the sine and the cosine graph, we're going to look at these kind of together when we talk about horizontal shifting. So up in the ante a little bit here, now we're going to talk about an equation of this form. So notice that the entire angle is bx minus c. So a is still the amplitude, and as we're going to find out, b still plays its same role, but let's just see what happens here. So we know that the graph of a trig function of this form has one full period when the angle goes between 0 and 2 pi. Now I'm going to solve each equation for x. So bx minus c equals 0. Add c to both sides, divide by b. I get c over b. And if bx minus c is equal to 2 pi, I'm going to call that c over b plus 2 pi over b. And the thing to notice here is, hey, wait a minute. That 2 pi over b looks familiar. This is your period, right? So we're going to call x equals c over b the starting point, okay? So let's just fill in the blanks here. Thus, the horizontal shift from y equals that to y equals that is, well, we're going to go right by c over b units. Now, this is not something that we're going to memorize. We're just trying to see how this plays out. So what we're going to do, every time we think we have a horizontal shift, we're just going to set the angle equal to 0 to find the starting point, okay? Another way we could look at it is just going back to basics from regular college algebra, which if it's x minus something, you know it's going to the right. If it's x plus something, you know it's going to the left. So pick your poison. So let's look at this example here. And again, I'm going to put the y-axis here where it belongs, okay? Now, I know the sign usually starts when the angle is equal to 0. So I'm going to say x minus pi over 2 equals 0, which means x equals pi over 2. And notice that there is no other shifting happening. The amplitude is 1. There's no period change because the coefficient of x is 1. So I can start this graph at pi over 2, and I know the period is going to be 2 pi. So I know it's going to end at 5 pi over 2. And just remember everything that you know about sine. Halfway between the external intercepts is the internal. It's high in the middle of the first two and low in the middle of the second two. And there's what my graph looks like. And you know, just for effect, I'm going to graph one more period if I can fit it in. And I get most of it. So let's just pretend there's a 9 pi over 2 here. And that does that for us there. And something interesting to notice. I'm totally getting off the beam here. Okay. Let's try this again. Okay, so at pi over 2, we should be seeing 0. At negative pi, we have 1. There we go. Okay, I was on the right track then. Not sure what was going on there. Okay, so notice, and you can look at the graph if you want to, this is the same as y equals negative cosine x. In other words, it's the same as cosine x reflected. So what we're getting to see here is that there's a little bit of a foundation of trig identities happening here. So let's stay tuned with that. Okay, we want to graph at least 2 periods of 2 cosine x plus pi. First thing I'm going to do, set the angle equal to 0 so that I know what the starting point is. So technically the starting point is x equals negative pi. Now, the 2 tells me I have an amplitude of 2. And since it's cosine, it normally starts at the high end, right? So putting all of this together, x equals negative pi is where I'm starting, so right there. I'm sorry, x equals negative pi. The amplitude is 2, and cosine starts on the high end, so there we go. And there's no period change because the coefficient of x is still 1. So I'm going to count over 2 pi units to get the end of the first period, and then 2 pi more units to get to the end of the second period. Halfway between the 2 highs is the low, which I know is negative 2. And then in between each high and low is an intercept. So here is 2 periods of this cosine graph. And we could keep this train moving if you want to. 3 pi, 4 pi, low point. There we go. Okay. Two more, and then we'll move on to horizontal. We'll move into vertical shifting. So 2 periods of sine of 4x minus pi. Now here again, I'm going to say 4x minus pi is equal to 0, which means 4x equals pi, which means x equals pi over 4. So that's the start. So I'm starting at x equals pi over 4. Notice, no amplitude, right? The amplitude's still 1, but I do notice that my period is 2 pi over b, which is pi over 2, which means my graph starts at pi over 4, which will be right here, and it's a sine, so it starts in the middle. And then by the time I traverse pi over 2 units, I've already covered the whole graph. So that means right here. Okay, so this is going to be really fun. So that means in the middle, we have the other intercept. In between these two, we have the high. In between these two, we have the low. So there it is on that scale. It's almost one of those blink, if you blink, you miss it kind of thing. So we'll do this again. So pi over 2 units for the whole period. Halfway between for the second intercept. Up, down. And that's going to keep going. I'm not going to, we could probably fit about 15 of these things on this grid, so we're not going to do that. All right, last but not least, looking at horizontal shift. Notice it's a cosine graph. Notice right here, this says I'm reflecting. And let's look at the angle. So we have pi x over 2 plus pi over 2 equals 0, which means I have pi over 2x, I'm going to write it slightly differently, equals negative pi over 2. Well, that, by inspection, I can say x equals negative 1. So my starting point is negative 1. Okay, as far as period goes, it's 2 pi over, the coefficient of x is pi over 2, which turns out to be 4. So isn't that nice? And my amplitude is 1, but it's reflected. So we have to put all of that together. All right. So I'm going to just pick this to be my y-axis. So I'm going to call that x equals 0. And that means that this is x equals negative 1 right here. So negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So cosine is reflected, which means this one's going to start low. So I'm starting here. And in 4 units, I'm back there again. Halfway between the lows, I'm at the high. And halfway between a low and a high, I have an intercept. So let's just repeat this process. And here's my graph. So if you continually remember that the relationship between the intercepts and the high and the low, you really don't have too many points to graph on these things. We already know what they're going to look like. They're all going to look like a wave. It's just a matter of where does that wave start and how often does that wave repeat. Okay, so next what we'll look at is vertical shifting, and that's going to be kind of the icing on the cake right now. So come on back when you're ready. Thanks for watching.